I got a couple that I want you to fill me in on.
Okay. Are you out of bed yet, Tyler?
I'm technically still in bed, but I'm not out of bed. So
You're good. You're good.
Camera off, pants off. That's the rule.
You're here. I appreciate you being here. That's all that matters.
I appreciate being here. So, question 3 and 4.
Okay.
They're all different though. They're not.
Yeah,
all...
they're randomized. So you're gonna have to tell me.
Okay. Well, how about 3 is A is 40. The
one where
is
alpha is how many degrees?
44%.
44 degrees.
Yeah, 44 degrees. My bad.
There it is. I found it. Okay. What color do you want me to make this?
Fuchsia.
Is
Yeah,
that what
that
color
one,
I am?
actually.
Okay, good. All right, good. We're good. I just need my frickin'. Where'd my frickin' thing go? Oh, it's in my hand.
Jeez.
Okay. Who did that? Who drew a smiley face?
I did.
How'd you do that?
I don't know.
That's sweet. All right. Well, Ben's going to teach Trig this
All
morning.
right. Hey, that's good.
Let me do the first one. You can do the rest of them, Ben.
All right,
I'll just take a nap while you're teaching.
That works.
Okay, so here's what it looks like. Ish. That's terrible. And then it's telling you this is 44 degrees.
Mm-hmm.
And if I'm you guys and I'm having any trouble with this, I'm going to draw this out on a piece of paper. It's telling me that this is 1,678 centimeters. And I need to find X, which is this one. Okay, step 1.
Oh, wow. I put a decimal point instead of a comma. So that's probably exactly why I got that.
Okay.
That
fixed
would
it.
help.
We fixed it.
It's not Europe.
So what is step 1? Good grief.
You get the opposite adjacent.
We're given relative to the angle an opposite and an adjacent.
So tan.
So step 2, we know we're using tangent.
So be tan 44.
So step 3 is tangent of 44
Well, if
equals
X over 1,678.
1678. Solve for X. X equals 1678 times the tangent 44. And what are we left with?
1,620.43 centimeters.
Niner?
Niner.
Niner. When I say what are we left with, that's me being lazy because I don't want to get my calculator out and do it. But I guess if you're going to make me, I will. C 44, 10 times 1678 equals that's what I got.
Same here.
Same.
Same.
Yeah, I didn't even attempt it. Looks good though.
Okay. Next.
I was good with the algebra. I just had problems with the calculator because every time I'd go to do one of trigonomic functions like sine, cosine, or tan, I'd want to hit multiplication instead of just hitting the button, and it would give me the wrong, it would multiply twice. I'm just not used to that kind of stuff. I'm used to taking the picture and then letting the app answer it for me.
You go over another one?
Yeah, can you do one with, I don't know which one it is, but where the unknown is with the like tangent, sine, or cosine?
Finding the angle?
Yeah, that sounds great.
Sure.
Do I need
alpha.
to step up back, or do you got this one?
What? Ben's
I said,
going
what
to do
is-
this. Ben's going
Alright.
to do this one.
Sweet.
Let's do the one where x is 133 centimeters, and we're finding alpha. I'm going to take a nap.
You want to erase your work for me?
Yeah, just come. Oh, you don't have. Can you not see these things up here?
No, I can't. I can't erase.
Okay.
I can't erase your work. I can only erase my work.
There
There we
you
go. Sweet. All right. Man, look how beautiful that is.
Jealous?
What? I'm sorry. Am I bothering you?
No, you're good. I'll keep working. All right. Let's see. That there.
Why did you choose the color piss yellow?
I can erase it. Hold on. There we go. It was just the default on it.
Okay,
Don't
All
let
right.
Zach intimidate you.
No, that's all right.
you're good.
We are strictly fuchsia and magenta over here.
Mhm.
Chartreuse. We'll allow chartreuse.
All right. So, all right. What are we dealing with here? Put an unknown there. Oh, that's that. I don't know what that is.
Sloppy theta.
There we go. There's your theta.
All right.
And then
It's the biggest
Someone-
theta I've ever seen in my life.
I know. I have fat fingers. Someone pick a 2-digit number.
53.
38.
97.
I heard 38. We're going to go with 38. Here we go.
97.
And then we'll do like, I don't know, 42 here.
Yeah, looks about right.
All right, cool. So to find theta, what you do, so whatever it is, so it's opposite and hypotenuse, so it'd be sine. So you'd be sine of theta equal to 38 over 42. And then whatever the hell that is. 0.905, something like that. Anyways, you can do it easier. Just do the sine. The inverse sine is equal to that same thing. 38 over 42. And you can type that straight in your calculator. So sine inverse 38 over 42. And tell me what you got. I got 64.79
Same here.
for that angle.
All right.
I had two that I got wrong that I can't figure out.
What, Justin?
I got two that I got wrong that I can't figure out. And even when I'm looking at the answers now, I don't get the answers.
Okay. Which ones? Oh, wait a minute. Good job, Ben. Everybody give Ben a round of applause. You're not applauding around. Give him a round of applause.
That's okay. I'll take what I can get.
Oh, shit. Thanks, Ben.
Yep.
Excuse my language. Okay. Damn it. Sorry, I'm having camera issues. I want to make sure you guys can see my pretty face.
Yeah.
See it? Okay. What is that? All right, no, what was that? You're gonna have to explain what you just. That was very inappropriate what you just put on there.
It was just elongated C. Exactly.
Yeah. Okay.
I need to pause that recording, Zach.
Now I have to edit the video before I put it on YouTube so I don't get in trouble.
I was gonna draw Homer Simpson, but I forgot how to.
All right, Justin, which one did you want to see?
The one I got wrong. Well, I got two of them wrong. One of them was A equals 49 degrees, Y equals 2.7 meters. Find X.
A equals 49 degrees. Okay. So that triangle looks like this.
Yep, that's about it right there.
So if you redraw this and punch the things in, this is 49 degrees.
Yep.
This is 2.7 meters.
Yep.
And we need to find this, right?
Yep.
Step one.
So step one, I got X was the hypotenuse,
Hypotenuse.
and then Y was the adjacent.
Sine.
This is not adjacent.
I thought, you know what? You're right. That's opposite. I did write opposite down though, didn't I? I think I did.
So algebraic refresher for me, you multiply by x when you do the formula out, right? So that you can get it out of the denominator.
Yeah,
Both
you
sides.
For
do
this
that to both
example,
sides.
Yeah.
for this example, Nick?
Yeah.
Yeah. Okay. Well, let's go through the whole thing and I'll do the algebra, the long form.
All right. Thank you.
2. What is step 2? Justin, which trig function are we using?
Using sine.
Sine. So what is step 3? Set up the formula.
So I got sine 49 equals 2.7 over X.
Yep. So I'm going to make some more room for me here. Sine of 49 equals 2.7 over X. So if we're solving for X, the first thing we do is get it by itself on one side of the equation. Multiply both sides times X. Those cancel, and you're left with X times the sine of 49 equals 2.7. divide both sides by sine of 49. Those cancel, and you're left with x equals 2.7 divided by sine of 49, which equals 3.58.
You said 3.58? Oh, damn.
Yeah.
Yeah. Okay. Yeah.
You good, Justin, on that one?
Yeah, yep. I was doing some stuff wrong. And then the next one, which I probably can figure it out now, because I probably did it the same way I did number 2. But it was A equals 28 degrees, Y equals 147 centimeters, sine X.
I see it. So this is 28 degrees. Okay, this one's a little sketchy because it's not to scale.
I was gonna say, is that a right triangle?
But we're gonna yeah. But you see what I'm saying? Like, it's telling you that this is 28 degrees.
And that doesn't look like 28 degrees
This
at all.
one looks more like 28 degrees, but we're just gonna solve it how the numbers are, okay? So it might not look right according to the picture, but we'll solve it how the numbers are. So then it's saying this is 147. And it's saying we need to find this. So step 1, what are we given?
Opposite and adjacent.
Yeah.
So it's going to be the tangent.
So 2, we know we're using tangent. 3, we're going to set it up. Tangent of 28 equals opposite over adjacent.
Tangent of 28 is...
So I can do the long algebra if you want, or I can...
No, that I got that.
Okay, so x equals 147 over the tangent of 28, which should give you 276.47.
Yeah. I don't know how I got the other ones right because I wasn't doing none of them this way. I don't know how I got them right.
Got lucky.
I did.
Divine intervention.
Mm-hmm.
I did. Well, because what I was doing was when I got to like the 1028 and I removed the X, I just took 1028 times 147. And I was getting wrong answers and I couldn't figure it out. But that's how I did all of them. Like I would take when it was just the degrees, I took the degrees times whatever the given value was. Well, the tangent or cosine, whatever that is, I would take it times whatever was given. It was giving me, like, I'm assuming right answers. Go figure.
Yeah. First time I did it, I got like 53 for the first nine questions. I was like, that's not right.
Now, the ones where I was given both sides and had to find the degrees, I did them this way right here. Well, not exactly this way. I had to do the reverse or the opposite, like the -1, tangent -1, or I had to use that sign, but the setup was the same way. But the other ones I didn't do this way, so I guess I learned something new today.
Right. That's why we're here.
It's not very often I learn something new. When I do, I cherish the moment.
Stick with me, Justin. You'll be wearing baseballs the size of diamonds.
I'm not a baseball fan, so I don't understand the analogy.
All right.
Switch it to basketball, maybe. I might figure it out. Those are the only two I had. I don't have any. I got all the other ones right, I guess.
Yo, we're getting real interactive right now.
I'm just playing. So it looks like we've done this one. That's correct.
You making some battle plans there?
Every time I see tangent, I'm gonna think baseballs and hearts.
All right. Should we move on?
Sure thing.
You want to do any more trig practice?
No, I'm good.
Okie dokie. I'm gonna get back to where we left off on Wednesday with the PowerPoint.
Okay.
I think we did through methods of bending, right? All right, now we're getting into the types of bend. I think what I'll do is I'm going to briefly go through each of these different types of bends, and then I'll do some examples of how to bend them and what to measure and all the different things associated with them. So,
okay.
Stub 90. Morning. Yeah. Oh.
Clean regardless.
I don't know. Thank you. Consider it clean. I won't sneeze on anything.
Is this PowerPoint available to us on the shared drive?
No, I was going to, but then you download it and you just use it on the quiz and you don't learn anything.
Okay.
Sorry.
No, that's fine.
I'll give it to you after the quiz.
Okay.
No, that's okay. Don't worry about it.
Who's drawing on this? How are you doing that?
Magic. I like how it stays wide.
That's what I'm want. Like, how are you? I'm gonna have to change some settings here.
Oh, I don't know about that.
Show names of annotators. It's not showing.
Great.
Oh, try it now.
Dang it.
Did I?
Yep, you stole it from me.
Gotcha. All right. I'm going to change it back because I don't care as long as we're not being inappropriate or anything. Listen to me saying let's not be inappropriate.
That's appropriate.
I think me telling you what a stub 90 is going to be a little bit ridiculous because it's pretty obvious. But this is a stub 90. So I think what I'll do is just do an example of each as we go through them. Okay. And then so for the stub 90, I'll show you how to measure. We talked about take up a little bit the other day, right?
Yep.
What the radius of the bender actually takes up when you're measuring. Gain, we'll talk about that a little bit. And then we'll get into back to back. Okay, first bend, stub 90. Here are the ones we're going to talk about. I'll back up. We're not going to do rolled offset. Once you know how to do an offset, rolled offset is just using math to, it's if you're not going straight up or down with the offset. But you are going to do a 3-bend saddle. You're going to do a 4-bend saddle, stub 90 and a back-to-back 90, and an offset. By the way, let me show you real quick 2 things. Your lab assignments for this class are going to look like this. This is about half of them. These are not your names. I will put your I'll put your names in there, but you're going to need to do a stub 90 with a 7-inch stub, back-to-back 90, 7-inch stub, 32 inches apart, offset, 6-inch height with 45-degree angles, 4-point saddle. No, last one was 5. 6-inch height, 45, 6 inches apart. And at least one of these needs to be 3/4 EMT. So that's about half your labs. And I need to take a picture to show you what your other ones are. So give me a second here. Who did that?
Did what?
Farted.
Oh, no, it wasn't me.
I can taste it.
Oh.
I thought I was on mute.
I wasn't muted. It sounded like you had eggs for breakfast.
I don't know if you guys actually heard mine or not, but I had steak.
Steak?
Yeah.
Imagine your name being last name being Jenkins. That's great.
So this.
That's the offset, ain't it?
This is
That
going to
looks
be
like a
your
saddle.
other set of labs. You're going to have to replicate what I have here, but this is an offset right here.
Okay.
This is a 4-point saddle.
Yeah.
1, 2, across, back down, and over. So there's 2 bends on that piece of pipe. This is a coupling right here.
90.
Then you're going to need to do a stub 90 and then a little box offset here. Okay. So what's going to happen here is I'm going to label this with like a Sharpie on the pipe itself. Excuse you. So this will be like pipe 1, pipe 2, and the third one, which I haven't put mine up there yet, but it's just going to be a 3-point saddle out of here, running along this wall, 3-point saddle over this pipe, and then back. And you won't have to hit any like box or anything over here.
Okay.
The whole point of this is to be, you know, the first set that I showed you, these ones, you're just given a measurement and you need to bend a pipe that comes up to those measurements. This one, you're going to actually, this is real life. You're going to have to measure, where is this strut, you know, put the 4-point saddle right to the middle of where that strut is. And then you'll get some experience with the conduit hangers too. So like you'll use strut straps for this, 1-hole straps over here, and then I might put some minis on the 3-point saddle. So just to give you a rough idea of what you're going to have to do for labs. How do I clear all the...
So when we do the 3-point, will there be a specific angle that you want us to take over it?
It'll need to be 45.
What was the question?
Will you give us a specific angle to take over it?
For what?
For the 3-point? Yeah.
You're going to have to match mine.
Okay.
So what does this look like here? Well, you'll be able to tell when you see it. It's hard to tell. And actually, I can't even tell from looking at that picture. But
Look at the shadow.
yeah, look at the shadow. It looks like 45s. But I could be wrong. Anyway, we need to learn how to make these bends first. So,
all
right. Stub 90. I'm going to change cameras and show you how to bend a stub 90. You can use this picture for take up. This is a good picture to use if you want to pull this up while you're doing your laps, but this is how you bend a stub 90. So what they're saying here is I want to bend an 8-inch stub 90. The take up, or some people call it deduct, is 5 inches. So what size conduit is this? Knowing that.
1/2 inch.
1/2 inch. And that's what I'm going to be doing demonstrations with you, is 1/2 inch conduit. So if I wanted to make an 8-inch stub 90, I would make a mark how far away from the end of the pipe?
1 inch.
3.
1? Where are you getting that?
That graph.
No, I want this to be 8 inches tall, right?
Mm-hmm.
So I come down 3 inches, make a mark, make the bend, and then the take up is this 5 inches. It's the room that you need to make a 90-degree bend with this bender, right?
Right.
So I'm gonna do an example. I'll make it 11 inches or whatever you guys want. What do you want to do? You want me to match this or do a different one?
It doesn't matter. 34 inches.
34? That's a waste of pipe. Jackwagon.
Girlfriend said.
Somebody pick a number between 8 and 15.
9.
Niner. We got a 9er again. Okay. I need to switch cameras here. Bloop. Pin my video so I can see what I'm sharing. There's my butt. I hope I can get all of this in there. So first thing you guys are going to have to do is probably, which you don't have to because in the lab there's plenty of room to work with. But this is a piece of 1/2 inch EMT. And they come in 10-foot lengths. So if I'm making a 9-inch stub 90, I don't need 10 feet of pipe, right? So I'm just going to cut this thing in half. In the back of the lab, there will be this is called a tripod vise or a chain vise or whatever you want to call it, but this is not a chain. So there's one of these, and then there's another vise like this mounted to a table in the back. And then when you guys are cutting your pipe, you get to use one of these. You ever used one of these before?
Oh yeah.
It's a jack saw. I am going to use the hacksaw one time, and then I'm going to use power tools after that because I'm lazy. But I want you guys to use hacksaws because jerk. This is pretty self-explanatory. It's got a little doohickey there that's right on the table.
Is the one finger technique, is that
Huh?
the one finger technique required, or is it?
You can use your index or your pinky,
Okay.
always clockwise. Okay.
Pinky seems. Yeah.
Get it? Got it? Good. All right. I need a tape measure. Be right back. Will somebody tell me where I need to cut this pipe? Trick question.
12 inches.
Not a trick question. I'm just messing with you. I told you I was going to cut it in half. So, you know, about 5 feet. Real life pipe bending stuff. You always want to use a pencil. You can use a Sharpie if you want in here because I'm not going to judge you. But a couple of different reasons you want to use a pencil to mark the pipe. One is because you're going to make mistakes. I make mistakes all the time. I got a marking pencil there. I'm like, oh, that's wrong. Just rub it off. And keep your minds out of the gutter. Rub it off. The other thing is when you put a bunch of pipes up nice and pretty and you want it to look nice and aesthetically pleasing, you don't want to see a bunch of Sharpie marks all over. It looks like crap. 5 inches, 5 feet. Right there. This thing, and if people put the blade in the right way, just so you know, and I want you guys to use a hacksaw because it's real life stuff. I'm not just being mean. But the teeth on a hacksaw face forward. I don't know if you know that. So the cutting on this is always when you're pushing, not when you're pulling. But I don't care if it takes you an hour to cut a piece of pipe. I'm not grading you on how to use a hacksaw. Just be safe. Don't cut your finger off. Wear safety glasses like I am. This needs to be tightened.
You get the porta band.
Huh?
Grab the porta band.
I have a quarter band.
I know. Just cut that sucker.
But I don't understand how to tighten this thing.
There's not a wing nut down there?
No.
Highfalutin.
Yeah, that's what it would do. A little bit. Okay, so I got a 5-foot piece of pipe. What do I need to do next?
Burr.
Deeper. What's that called, the thing?
Reamer.
Reamer.
Good old infamous drug.
So proud of you guys for knowing that. So this is the reamer, same one as it's on the PowerPoint. This one's made by Ideal. Oh, another handy thing about these is You guess what that's for?
Actually, no. I don't know what that is.
These fit different size wire nuts. So,
Oh, God,
so if
really?
you don't want calluses on your fingers, you can use this to tighten your wire nuts down. It's kind of a pansy way to go about it, but
Thank you. I didn't want to be the one to say that.
I figured you'd be the only one using it.
Oh,
Oh,
actually, we're
so
recording.
I just deburred the pipe. All right, now I'll show you that. Look, very deburred.
All right.
Very, very, very deburred. Now what?
Start your measurement from the end, right?
Yep. So how tall are you making it? I forget.
9.
Niner.
9er. So you'd measure 4 inches from the end.
Very good.
It's like clearance.
So why are we measuring 4 inches from the end? Can you repeat like why?
So that's the take up. So
Okay.
when you actually bend the pipe, so you're putting the line in line with the arrow at the end of the bender.
Okay.
So then when you do the 90-degree bend, it's going to add 5 inches to
Okay.
whatever length is from the stub.
Okay.
Thank you, Brian. It'll become more clear when you see me do this. So,
Sure.
just to make it more practical, let's say I have a box that's, okay, 9 inches from this. So here's, I'm just measuring 9 inches. So here's a, let's say it's just a handy box, and it's got a little 1/2 inch fitting right there. But this is the measurement that I need to get to. You can all see that, right? Yep. So this is 9 inches from here to the ledge. So when I mark this 4 inches away from the end, the take up of the radius of the 90 is going to take up the other 5 inches.
Okay.
So if I do this right, which I always do because I'm perfect,
I'm just wondering how you know to mark it at 4 inches.
you'll see.
Okay.
Oh, how do I know that?
Yeah.
Look at that slide that says take up.
Okay.
And you will have this chart with you when you take tests. But
Okay.
take up, or some people call it deduct. Thank
Sure.
you, Ben. It's 5 inches for a 1/2 inch hand bend.
Okay.
That just means that this is going to take up 5 inches of space.
Okay. Gotcha.
Now, that's not the same for the hydraulic benders, right? They have a different number?
Well, yeah, because the radius of those shoes is different.
Different. Okay.
So
yeah.
you would have to test bend a piece of pipe and figure out what the take up for those is. Some will say, the shoe will say it on there.
Yeah.
Okay, so 4 inches. And you're going to see when I bend this that the radius of the bender is going to take up that other 5 inches.
Okay.
All right, so I can't tell who's asking that question.
Nick.
Okay. Okay, so for a stub 90, what mark on the bender do I use?
The arrow, right?
The arrow. So that's right here. The arrow means the start of a bend. That doesn't matter if it's 90, 45, whatever. That's this mark right here. So I'm going to put this in here so you can see, hopefully, where I'm putting that mark. Okay, so this is 4 inches, and I'm going to bend this all the way around till there's no 90-degree mark on here, but you'll see what I'm doing. Like that. A lot of people will start this bend with the whole thing laying on the floor. I always start it from up here because then I can make sure that the mark stays on the arrow before I start bending. Some people will put it on the floor like this, but when you do that, I'm lined up on the arrow. When I take this to turn it around, the whole thing can move. And I don't like that. So this is just the way I do it. I start the bend standing up. And then I turn it around, and that helps keep the mark on the arrow. So, just so you can see it. Okay, then when you bend to 90, you want to put your foot on here and put pressure down as you're bending it, because hopefully I can do an example so you can see this, but can you see if I'm just pushing on this, what happens to the pipe right here?
Yeah.
If I'm just pushing down that lever, it lifts it up off the ground, right?
Yep.
It'll actually put a little bow in the pipe right there. So you want to put your foot on the shoe and push down while you're making the bend. And then you're really just eyeballing that 90 until it looks like it's straight up and down. Then when I take the shoe off and turn it to the side, I can tell that it looks a little open. So what open means is if this is straight this way, it looks like it's my foot. It looks like it's open a little bit. So this would be closed. This is open. Nice thing about half-inch EMT is it's really workable. So does that look a little open to you? It kind of does, doesn't it?
Yeah.
Yep. So what you can do is just put the end of the pipe on there and give it a little slap and tickle. Does that look better?
Yeah.
It looks a little closed.
Looks a little closed? Jeez.
Yeah, slightly.
Slap and tickle the other way.
That's good.
That
Okay.
looks more true, yeah.
Looks more like
That's right. And if our math is right, this should be 9 inches tall. Should we check?
Yep.
Moment true. We do. Is that perfect or perfect?
Good.
You understand what take up means now?
Yeah.
So here's my mark. This is 4 inches. The radius of this took up 5 inches worth of space.
Okay.
Got it?
Yes.
Okay, the other thing that we need to be aware of with a stub 90 or any 90 is something called take up, or excuse me, gain. No, I'll just draw it on here. Gain is if this was when it was straight, how long was it?
It was 5 feet long.
5 feet. It was exactly 60 inches. Is that right?
Yeah.
Exactly 60 inches end to end. When I put a little radius on there, that means that this distance from here to here added to this distance here to here. How many inches do you think that's going to be? If I just call this A and this B, what is A plus B?
It's 60.
It's actually going to be a little bit bigger than 60 because we cut this corner.
Oh, so it'd be what? You said that's 9 inches going all the way up, right?
Yep.
So it'd be 69.
We know this is, no, this is not, we know this is 9 inches. I have to measure this, which I will. But understanding that this is going to be more than 60 inches is because of something called gain. And what gain actually is, if you look at the slide, it's this little area right here. That's gain. Because all it is that we're cutting this little corner. This is important because if you're running 2-inch rigid, you know, this thing, if I get this wrong, or if I'm coming from a box or coupling that's right here, I make my stub 90, and then all I have to do is cut the pipe off right here, right? It's pretty easy to cut 1/2 inch EMT, but if I'm running 2 or 3 inch rigid, I want to have this thing cut to length straight before I bend the 90. So I need to figure out what gain is and subtract it from this piece before I bend it. Does that make sense? Because I have to cut and thread the pipe and then bend it.
Yeah.
So I know I'm going to gain a little bit when I bend it up, so I need to account for that. But anyway, let me measure this for example. We know it was 60 inches when I cut it, right? Yes, no?
Yes.
Yep.
Yes, we sure did. So this is, I'm going to call it 53 5/8. So A is 53 5/8. B is 9. So add those together and you get 62 5/8. So what is the gain for this bender on stub 90?
2 5/8.
2 5/8 inches.
Right, so gain is going to be 2 5/8 inches. So that being said, if I was coming from here and I wanted to know exactly what to have this pipe cut at before I bend it, I would take this measurement from here to here plus 9 inches minus the gain. Make sense? And you won't have to do anything like that for quizzes or tests.
Okay.
Or you won't have to figure gain in the lab. But I will tell you that you might on a quiz see a question that's like,
How do you figure the gain or something like that?
no, let's just erase these numbers. So we figured out the gain is 2 5/8 here, right?
Yeah.
If I told you this was a 10-foot piece of pipe, and I told you A plus B is 123 1/4 inches, what would the gain be for this bender?
3 1/4 inches.
3 1/4, yeah. Right, you understand that? Or if I told you this was a 9-foot piece of pipe, and then I bent a stub 90, and I told you that the gain was that 2 5/8, what would A plus B there be? So it's a 9-foot when it's straight. I bent a stub 90, don't care where, don't care how tall. If it was 9 foot and then I bent a stub 90, when the gain is 2 5/8, what would A plus B be?
It'd be 2 5/8 plus the original length. That's...
Yep. 9 feet, 2 5/8 inches. Right? That's really all you need to understand about gain. If you become an expert pipe bender and you're doing this all the time and you're running big conduit like rigid, you're going to want to know how to account for gain, because you want to have that pipe cut and thread before you bend it.
Okay.
You know why? Why would you have to have that thing cut and thread before you bent it?
Cost. You don't want to throw away a whole bunch of pipe, and if you're bidding a job, it'll cost you your job if you lose.
Cost. It's a time saver.
Yeah.
And the other thing is, look at
Makes it easier to get in the right position.
exactly. This is a triple nickel, so this is what I'm going to use on the job to bend a stub 90 with a 2-inch piece of rigid. For me to cut this, to bend a stub 90, and then take that pipe and put it in a threader and try to thread it, number one, it might not fit.
And then you're doing it mechanically.
Yeah.
Pain.
Or mechanically. I mean,
yeah.
If I bend a stub 90 with this, I still have to cut it and thread it, right?
Yeah.
Why just being so slow? Yeah, anyway, you get what I mean.
But like most of the contractors that we hire to do the big stuff, they'll bend everything because they bid it out and they don't want to pay for it. But if we're doing it, we'll get it pretty close, and it doesn't have to be as exact because we just put a Myers hub on it and let it run.
Yeah. Yeah, I mean, the good thing with rigid pipe is you do have the length of the threads as wiggle room, you know. But for what you guys are doing, you won't have to worry about that with the hands-on stuff because we're working with EMT. EMT is great because you just cut it wherever you want, you know, cut it to length however you want, and it's cheap.
Yeah.
So let's take a little break.
All right.
And come back in about 10 minutes, and I'll go over the next bend.
All right.
Jeopardy music time?
If you want, man. It's
I'm
up
just
to you.
kidding. I won't do that to you again.
It's your world.
moving on. You with me? Hello?
I'm here.
I'm here.
Here as well.
I'm here.
Also here.
What'd you do with my eraser? Here it is. All right, we did a stub 90. Everybody's an expert on stub 90s now, right?
Absolutely.
So now I've got another box. Over here. Just so you know, it's hard to hold a
Level.
level on a whiteboard. Now I've got another box over here. Right here. Maybe right here. This should be enough. Another handy box with fitting coming out the bottom. So this distance should also be 9 inches. Right?
Right.
And let's say that there's a bunch of crap right here in the way. That looks really inappropriate. There's a big ball of crap in the way right here. So we can't just make a straight pipe box to box, right?
All right.
Make sense?
Yep.
So what kind of bend do we need to put in that? Back to back 90 is the next bend. Basically, we got to take this doodad and bend another 90 straight up here. Okay, so looking at your PowerPoint, what mark on the bender do we need to make?
The first one you use the arrow, and the second one you use the star. Is that right?
Yes, very good. The star is used. The star is the back of a 90. So if I put it on the star right here, I have a mark here for the star. No, actually, it could be here. It's the star tells you where the back of this 90 is. So basically, this spot right here.
Okay.
I'm going to erase all that so it doesn't get too confusing. But, so I've already got the stub 90 on this side. So this is how you would bend a back-to-back 90 if I hadn't started already. But I got these two boxes, crap in the way, so I know I got to bend a back-to-back 90. I bend my first 90, exactly how we do the stub. And then the second 90, I need this measurement right here. So this is important, you know, for quizzes and stuff. To measure for a back-to-back 90, we measure outside to outside. Maybe I'll do this in a different color because I'm fancy. I'm bossy. I need this, and I need this. Okay? Those are the two spots I want to measure. Not center to center, not right side to right side, left, outside to outside. Because I'm bossy, like a boss. So I'm going to take that measurement right quick. And I'm going to say it's 28. Oh, let's call it 28 and 5/8. Okie dokie.
All right.
Did it? Got it. Good. So the nice thing about back-to-back 90 is the second mark you put, the star.
Yeah.
We're just measuring that, and that's it. 28 and 5/8. If I put that on the star and bend it up, that stub will end up exactly at 28 5/8 inches. So in order to do this, I'm going to make a little mark here because it's going to be hard for me to measure this at the same time that I'm doing that. So I'm going to make a mark on the. And I'm going to just use this straight edge because I'm bossy. 28 5/8.
Yeah.
So I just made a little mark on there. So I'm going to do this. And then a lot of times what you're going to have to do is take your mark and transpose it all the way around the pipe because you don't really know where you're going to be able to see your marks. So this distance is from here, the backside, to this mark is 28 5 inches. Got it? So I bent this 90 like this, right?
Yeah.
You always have the point of the shoe facing away from you, facing away from the other bend when you make your second bend.
Okay.
So that is like, right?
Yep.
I'm going to put it there. Just want to make sure you guys can see me. Eyeball down here. If you don't do this part, you'll end up with what's called a dog. And I'm going to show you what a dog is after I finish. Don't let me forget. Make sure that I'm bending this the right way. I might not be doing this right. Okay, so same thing as last time, and I already screwed up. Damn it. What did I do wrong?
You didn't put it on the star?
Didn't put it on the star. How am I going to be able to fix that?
Bend it back. Put your foot on. Step on it. Hard.
I'm working on it. I'm going to try it anyway just to see what it looks like, but I really should just start over. Why did you let me do that? Yeah, see, screwed it up. Trying to fix it, I screwed it up. So that's junk pile. Now I got to start over. What was my first one? 9 inches tall stub.
Yep.
You can do that. Remember when I told you that I never make a mistake?
Yeah, you say it all the time.
Still don't.
Was that our mistake then?
Yeah, because you let me mark it, or you let me put it on the wrong mark.
That's logical.
It's not a mistake, Zach. It's a happy accident.
Happy accident. I like that.
Was it a teaching moment?
I think they call that a teaching fart in the biz. It was a teaching fart. Okay, 9-inch stub. Mark. $28 in the what? 28 in the which what? 5/8?
5/8.
know if I do this the right way because you guys are going to correct me. Not the arrow. Ready? Zach's a dumbass on 3. 1, 2, 3.
Zach's a
Zach's a
dumbass.
dumbass. Thank you. Putting it on the star. And then eyeball it.
So you're putting your mark on the star, is that what you're saying?
Yes, sir.
Okay.
Hopefully you can see what I'm doing. It's like looking at my butt. If I did this right, outside to outside should be 28 5/8, or it should end up right on that coupling. If I did it wrong, I put it to the right. Oh, that's way off.
Toast but no cigar.
No, you're inside of it a little bit. You bend it out.
Yeah.
Is it closed?
Yep.
I don't understand. That's too far off to be closed, and I did something
Yeah,
wrong.
it's not closed. It's just off.
I did something wrong.
Measurements probably. Got to be a measurement error.
Did you forget the gain?
20. No, gain doesn't have anything to do with it for back-to-back. It's 28 5/8, and the mark that I put on here is 27 5/8.
That would be why.
Well, you can just erase the picture and redraw it.
Yeah, this is what. So this is real life. So what you do is you put another coupling on there that's 27 5/8.
Obviously, it's a not calibrated tape
Right
measure.
here. So this is the actual coupling we're going for. Makes sense, right?
It's a gang box. You're just going
27 5/8. Then you bend it. Look at that. Perfect.
It is.
Right. So I guess the lesson learned there is that if you measure right and use the right marks, you'll end up with what you want. I didn't, and I'm not going to waste another piece of pipe, but sorry for the horrible demonstration.
That's good.
These are also called, so this is a back-to-back 90. These are also called a bullhorn. If you ever hear somebody on a job say, hey, I need a bullhorn, it's this tall, blah, blah, blah. It's this because it looks like a bullhorn, right?
Yep.
Ferdinand.
Gotcha.
We got the using EMT, we hit our marks, and then all we did there is just cut that off at 9 inches. Cool, so that's a back-to-back 90. All right, what's next on the PowerPoint? Offset?
Yeah. So if we have to mimic your offset, are we gonna have to figure out what multiplier you used in order to figure out what angle?
That's a good question. We haven't even talked about multipliers yet. Basically, there's two ways of using this math. I'm a trig guy, so I use the trig. That's why I taught it to you. The other way is using multipliers. I'm not going to talk about multipliers yet until we do examples with the trig.
Okay.
Okay. So on that, is anybody on Blackboard?
I'm not.
Yeah.
Oh, never mind. Never mind. I'll just use this example. It's behind me. I just got to grab another stick of pipe. Be right back.
Oh,
So this is going to piss you all off because you're not allowed to use this, but remember the hacksaw thing? You want safety glasses for that. It's my new favorite tool, by the way. All right. Everybody good on stub 90s if I erase all this? Do you still need the word crap on there?
No.
Good. All right, so I'm running this bad boy along the chalk ledge again. And I've got a fitting on the outside of this box that I have to get into that's right here. Okay. And I'm running along this chalk ledge, and let's say my last stick that I ran, so I'm running this way. And I've got a stick and a coupling is right here. So I've already got a pipe coming in here. Okay. So I need to get from here over and into this box. So I'm going to bend what's called an offset. And all it is up, over, and over. At this point, you get to choose whether or not you're going to use 30s, 45s, 22 and a half. I will tell you that the easiest thing to do if you're going for easy is to use 30s, because I'll explain later. But for this short of a space, I might not have room to use a 30-degree offset. See what I'm saying? So just eyeballing this, I would say we probably need to use 45s, which is closer to what this thing looks like. So the mark that we need to know, or the distance that we need to know, and I always tell people, think of an offset like you're going over an obstruction. So like, let's say there's an I-beam right here. Okay, and really there's no obstruction there. We just have to get up and into this box. But this then is the distance that we need to know from here to here. So I will measure that. We'll call it 9 3/8. Got it?
Okay.
I need a 9 3/8 inch offset. Recap. Measuring for a stub 90. Measuring for an offset. For a stub 90, you need outside to outside. For an offset, you need bottom to bottom. So that's why I tell people, think as if you're going over an obstruction, right? That's the measurement that you need. In this case, we got to get from the chalk ledge to the bottom of this fitting. And that's 9 3/8. Okay, so now we start to figure out, why are we using all this trig? Does this sort of look like a triangle?
Yes.
Now you understand why we're using trig. There's another way to do this later that some people find easier. but my mind works more like this, so I use this way. And it's up to you guys. I want you to know both ways, but you get to choose in the lab which way you're going to use. All right, so in this case, I've got this triangle, and I said I was going to use 45s, right?
Yes.
Which means this is a 45. Here's your right angle. What I need to know here for this pipe is where to have these marks. So on this triangle, what is that? What is this? This
Hypotenuse.
is the hypotenuse. And I need to know what this is, right? This is the height of the obstruction. I'll just call that O. So if we're thinking about, we're going over this I-beam as the instruction, what is the height of the obstruction?
938.
938.
Right.
So relative to this angle, what are we given?
Opposite hypotenuse.
So what trig function is that?
Sine.
So how do we set up that formula?
So it would be sine of 45, right?
Yeah.
Is equal to 9.375 over x.
So h in this case is hypotenuse. So if we solve for h,
Okay.
is 9 3/8 divided by the sine of 45. So what's the distance between our marks here? Anybody got a calculator?
13.26.
13.26. So that means the distance between our marks is basically going to be 13¼ inches. All right, so I'm gonna take a flat piece of, you can see over here. I'm gonna take this flat piece of pipe, and I know that I need to have two marks in here that are 13¼ inches apart. All I have to do is choose this starting point, right? There's gonna be some little distance here. I have to pick a number because I can't start bending right from the end of the pipe. And I'm gonna show you why. Where do I need to put my first mark?
The arrow.
On the arrow. I can't put the end of the pipe on the arrow because it doesn't really or barely grabs onto the lip of the shoe, right? So you need to have some kind of number for a starting point. A lot of people will just call it an inch. I use my thing is 2 inches. I always start 2 inches away just because it's my standard. I always remember 2 inches. So if I go 2 inches away and then another 13¼ because that's how far apart my marks need to be, that's my offset. Follow?
Right.
Okay, so that's what I'm going to do.
So you just measure back 2 inches, make your mark, and then do your bend.
You don't want to make the first bend before you have both marks on there.
Okay, yeah, but okay, I got you.
Yeah. So I don't know if you can see this very well, but I'm gonna come out 2. All that is my starting point. That's my first mark. And then my second mark is gonna be another 13¼ beyond that. So I'm gonna make a mark at 15¼ I hope that makes sense. So I'm at 2, 15¼ which makes these two marks 13¼ apart.
Right.
Before I start,
Maybe 7, not really 9. Solid 7. Solid 7.
What? Did you unmute yourself by accident? Did anybody else hear that?
I did.
Or
Yeah.
am I losing my shit?
Nope, I heard it.
Okay. All right. For an offset, you want to make sure you at the very least transpose your second mark because you're going to end up, you'll see what I mean, but flipping the pipe around and you'll lose your first mark if you don't do it. So I'm taking my second mark and I am making it go all the way around the pipe. Okay. So here's an offset. First mark, first bend, what mark am I using?
Arrow.
Arrow. And you're actually using the arrow for both of these. Okay, so to make an offset, I'm on my first mark. Hopefully you can see that on the arrow. And then I'm going to bend this thing down to, what are we using, 45s?
45.
45, which is right here. When I do this, and I'll try to get a close-up, where you stop is where this mark ends up at the bottom of the pipe. So I'm going to bend it, and I'm going to show you what I mean. And the last thing I'm going to tell you is it's easier to bend this pipe from back here, right, because I have more leverage, but that also will put a bow in the pipe. So if you can, if you're strong enough, if you're like me and you're heavy enough, you make, you want to be as close to the shoe as possible when you're pushing down so you don't bow the pipe. But anyway, I'm going to bend it down to 45. And it looks pretty good, so I'm going to stop and show you where, if I can.
Okay.
See if I can like this. You see how that 45 mark is running out to the bottom of this pipe?
Right.
People always get confused at that part. Where do I stop it? You want this mark, wherever you're aiming for, to be running parallel to the bottom of your pipe. Okay? Okay. Offsets are really easy. You don't even have to take the pipe out. So I just made my first bend, right, down to 45. I'm not even going to take the pipe out. I'm just going to lift up and push it through over to my next mark and then spin it 180 degrees. Got that?
Yep.
I'm going to do it again. Okay, so I just made my first bend at 45. I lift up on the pipe, push it through, and spin it 180 degrees. Put the second mark on the arrow. And here's where you want to eyeball down the pipe. Okay, so I made the first bend, spun it 180 degrees like that. So now I want to look down there like it's a gun sight and kind of level it up so everything's straight up and down to avoid that dog. And then make my second bend at 45. That's an offset. That is a 45-degree offset. I can tell right now that it's way open. Maybe, maybe not. Maybe just a little bit.
Yeah. It's not bad.
You see what I mean by open? It looks like this is running uphill a little bit.
Yeah.
So now I put it up to where I want it to be, and then I can adjust it however I want. If I did it right, it should be 9 3/8 inches tall. So it looks like I might have underbent this one a little bit. Now I overbent it. You can manhandle this or you can put it back in the bender to do it, but I overbent it, so I'm gonna, might as well show you how to do that. All I'm gonna do is put it in the bender, but backwards a little bit, and then just tweak it however I need to. You don't want to do a whole lot of tweaking with the bender because you'll kink it the way I did that first back-to-back 90. It doesn't take much. Oh, that's not good.
Almost.
It's good. Nice.
There we go.
Still a little bit overbent, but I can take a little bit out of both sides. And move it up. Or better. Nine 3/8 is Bob.
Yep.
About 9 1/8, so I'm 2 inches off, or 2/4 inch off. That's more like boss.
Boom.
All right. So that's an offset. Everybody get the math?
Mhm.
All right. Last thing I'm going to tell you, and then we'll call it a day. You understand why I need this trig to figure out the hypotenuse, right?
Yep.
We came up with this is 13 1/4 inches from here to here is what we need. Now I'm going to show you multipliers. This is the other method of figuring out what you need for that distance. See on this graph, hypotenuse multiplier for a 45 is 1.41. This is the method that a lot of people use too. So if I know that the multiplier for a 45 is 1.41, I take that multiplier times the height of my obstruction. So somebody do me a favor. Let me switch back to the camera. Somebody do me a favor and take 1.41 times 9 3/8.
13.22.
Hang on. 1.41 times 9 3/8 equals what, Tyler?
13.22.
So what do you see here and here? More specifically there and there.
Right.
Same thing.
Yeah.
Basically. So if you can do it one of two ways. I know the trig, so I know that whatever angle I want to do, all I got to do is this. Figure it out, scratch a piece of paper in about 10 seconds, and I got this. Other people either have this memorized because they do it all the time, or they have an uglies book with them and they look it up every time.
Page 166.
Thank you, Brian.
Sweet.
Whichever way you want to do it in the lab, I don't care. Whatever's easiest for you. I do it this way because I know I can do it right every single time, and I don't have to memorize anything, and I don't have to look anything up in the uglies book. But they're both correct. They're both the right way to do it. Okay? So let's do one more example. I won't bend it, but let's say I wanted to do this same thing with 30-degree angles. So this is going to be 30, and this is going to be 9 3/8. First, let's do the trig. So set it up. We got to look for H. I'll just run through it quickly since you guys are about ready to bail out anyway. So opposite hypotenuse, so I know sine of 30 equals 9 3/8 over H. So H equals 9 3/8 over sine of 30, which equals what, about 18 3/4?
Yeah.
Yes,
Weird how I knew that so quickly, like I'm a human calculator.
because the multiplier is 2
I'll show you
for
why I
30
do that.
degrees.
Yes, thank you. So 18 3/4. So what is the multiplier of 30? So this is trig. We know this has to be 18 3/4. So multiplier version of the same thing is, what's the multiplier for 30-degree offsets?
2.
2. And that's why it's easiest to use 30 degrees for everything, but you don't always have that luxury. So the multiplier is 2. So 2 times 18, or 9 3/8 equals 18 3/4.
Yeah.
Either way you want to do it, you're going to get the same or close to the same answer. I don't care what you do in the lab. I just want you to understand how to do both.
So I had a question for you.
What's that?
Since I don't run a whole lot of EMT at work, you know how when you have to do a box offset, with rigid, you can put a coupling on the end and then do your offset to, get it real tight. Is there any way of doing that with EMT, or is it too flimsy? Like, because most of them you can't really do it with a compression fitting, and you can't do it with the set screw fitting. So can you do it?
Box offset with an EMT?
Yeah, like a real tight one.
Yep, and you're going to have to do it for the labs, the ones that are mounted to the wall. But people will teach this a couple different ways. I teach the easy way because I'm lazy, but you can actually do the math. You can do like a 10 degree offset, make your marks and all that stuff. But what a box offset is, just so the rest of you know, is over here. Okay. So if this is a wall and I'm coming down the front of the wall and into a box, and at the top of the box there's a fitting, I need to do what's called a box offset, because there's this little bit of space here that I gotta get away from the wall to get into this fitting. So it's just this tiny little offset. You probably can't even see that. But that's the box offset. You can do it all this way, or you can do it how I always do it, and I don't want to waste this. Use this. So here's how I do a box offset. Same thing, I just put the pipe to the end of the shoe. I'm not measuring anything. I'm just giving it the old slap and tickle, right? Same thing, slap and tickle. So I'm at the end of the shoe, not measuring anything, not using any marks. And it's just a little bloop, another little bloop. And that's usually about that little 1/4 inch or 3/8 that you need. I don't know if you can see it, but
yeah,
that's what I do with EMT.
Okay.
And if you ran that down the wall, I don't know if I'm gonna be able to. Yeah, nope, I can't. I can do this though. You can see.
Oh, there.
You see this little offset here?
Yeah.
So if I grab a box, hopefully that would hit right on one hole. This, by the way, is a handy box. That's what this is called. So, it's a little bit underbent. Well, no, this way. Perfect. Okay, so that's a box offset. This little whoop. Okay, I won't make you measure and do all that stuff. You can if you want, but it'd be a little 10-degree mark, and then whatever that distance is for the hypotenuse. That's how far apart we would make those marks. I've always just kind of done it by hand.
All right.
Cool.
Yep. Well, yeah, I just doing those in the green layer. You get it at the end to make sure you got enough leverage when you start it off. You just put a coupling on it, right? And you can use the coupling to add length to it at the very end of the rigid, and then you can start it. I've never had to do it with EMT.
Right.
Usually we just get we just put it on unistrut.
That little shallow strut. Yeah, it usually works out pretty well that way. All right, folks.
All right.
Any other questions?
When are we going in to actually do some of the conduit labs?
Let's plan on Wednesday. On Monday, we'll come in, take a trig quiz. We'll go over the rest of the bends, and then we'll talk about scheduling and who's coming in to do what on Wednesday.
So do we not have the conduit quiz on Monday as well?
No, because we're not through the
Oh.
PowerPoint yet.
Okay, cool.
And we'll review a little bit too before we take that quiz.
Is the trig quiz we have to come in to campus?
Nope, we can do it from
Okay.
home.
Okay.
So is it going to be just like our homework?
Yeah, it's set up a little bit differently, but it's
Okay.
solving the things the same way. So.
Okay. Cool.
All right.
All right. Thank
Have
you.
a lovely weekend.
You have a second? Zach?
Me, yeah.
Okay.
Have a good one.
See you,
See you, Zach.
Justin. See you guys and girls.
Okay.
Hey, Zach,